Hey, what's up you guys, my name is Harrison and welcome to School of Swipe. So today we're going to be talking about completing the square. This is the second video in a series of videos talking about quadratic equations, so let's just talk about it. So completing the square is not exactly factorizing, because sometimes there are no factors, there are no roots in this equation, but it is just something that you need. Sometimes it can be a process of finding a root if it's not if the root has square roots and that kind of complicated stuff. So let's just get right into it. So first of all, let's talk about squares. What is a square? The numbers 4 is a square, the numbers 9 is a square, but 1 is not a square. Okay, maybe numbers such as 1, 4, 9, 16, these are squares, right? It's because 1 square, 2 square, 3 square, 4 square make up the numbers above. So when a number or equation is multiplied by itself, it produces a square. So even something like x squared is a very simple square, but it's x multiplied by x. I mean, that's why we call it a square. Okay, so something like this equation here, x squared plus 4x plus 4, is perfectly made out of x plus 2 multiplied by itself, x plus 2. So not all quadratic equations are perfectly made out of squares, but by adding or subtracting the extra numbers, they can become a square. So let's just take a look at some examples. So like the slide before, you can see that x squared plus 4x plus 4 is made out of x plus 2 multiplied by x plus 2. Okay, so when we look at this next one, it's not a perfect square because there's an extra 1 in the equation. So instead of writing x plus 2 itself, you can write this thing and it is plus 1. And similarly, this is not a perfect square either because it is short of 1. So it can be written as this and this. So completing the square, completing the square will turn equations either into this, or if it's a perfect square, or if it's not perfect, you'll just add or subtract an additional 1 or an additional few numbers behind it. So okay, so let's talk about this. So this is going to be our linear factor. We don't know what this linear factor is going to be, our x minus h. We have no idea what it's going to be, and this is k. So k is the extra number. So if you know, by some coincidence, our quadratic equation is a square by itself, then maybe k equals to 0, and we don't need any extra number to make it a perfect square. So we just need to find out what h and k are. We don't know what they are yet, so they're just placeholders. So but by expanding the equation and comparing the terms, we will find out what their values are. So here's the first thing. We will set up the equation. The equation is just x minus h squared plus k. Okay, we will expand it so that we can take a look at it in more detail and then group it according to the power of x, and then compare each term. So what it looks like is, when we expand this, we have x minus h squared plus k. So we expand it. So we have a plus b squared, and you should know this formula by now. It's a squared plus 2ab plus b squared. So if we take it and we apply it to this formula here, we have x squared minus 2xh plus h squared plus k. Okay, so we're done. So when we group each term, we want to group the terms according to the power of x. So x squared, there's only one term with x squared in it. X, there's only one term with x in it, which is 2hx. So I'm just writing it so that everything's in front and there's just an x there. And for the constant term, we have h squared and we have k. So we'll put this together. Alright, finally we are going to compare the coefficient of each term. So the coefficient again is the number right in front of the x. So the number for x squared, the number in front of the x is a 1 on the left hand side, and the number on the right hand side is also a 1. So we actually learn nothing, which is okay. We don't need to learn everything from x squared. So the coefficient of x on the left hand side is 8, as we can see here, and the coefficient of x on the right hand side is minus 2h. So we have 8 equals to negative 2h. So if 8 equals to negative 2h, we can say that 8 over negative 2 is h, and hence we can say that h is negative 4. Okay, so finally for the constant term we have, so I'm just going to write the constant term. We have 3 on the left hand side, the one without any x's, and on the right hand side we have h squared plus k. So when we substitute h squared, 3 equals to negative 4 square plus k, and hence we have 3 equals to 16 plus k. K equals to 6 minus 16 plus 3 equals to negative 13. So when we write everything back, we have to write it in the original format, which is this. So we found h, we found k. H is negative 4, k is negative 13, right? So when we put them all together, we have x minus h squared. Okay, so we have x minus h squared minus 13, and this is our completing the square form. So it will look like this. If I clean it up a little bit, it will look like this after we remove the bracket for negative 4, but that's our answer. Okay, so I can give more examples that you can try on your own, but I just need to keep this video fairly short, so I'll just continue to the next one. So what if we need to complete the square of this equation, and we notice that this equation has a 3 in front of it, so we cannot use this formula because because we have our 3x squared, and no matter how we expand this equation, we're not going to get 1 equals to 3, so we can't do that. So instead we need to set the right hand side, we need to set up this equation, we need to use this equation instead of this. So there's a 3 there, just like there's a 3 there. So alright, so this 3 and this 3, it is going to be it is going to work out. So when after we expand it, we'll have a 3x squared on the right hand side as well as on the left hand side, and everything else will proceed as normal. So let's just jump through how this works very quickly. So or you could just put it as a general form is you put it as a, and after you expand it, we can very easily see that by comparing the x squared term, on the left hand side we have 3, and on the right hand side we have a. For the x term, we have negative 6 on the left hand side and minus 2ah on the right hand side. But once we know that a is 3, we can sub that in, and we have h equals to 1. And finally, for the constant term, we have 1 equals to a h squared plus k. So we can sub in a, we can sub in our h squared. So oh, it's not complete. Okay, so finally we have 1 equals to ah squared plus k. So 1 equals to 3, 1 squared plus k. So when we move this around, we have k equals to negative 2. So if we put this all together, we have 3x minus 1 squared minus 2. And that's our final answer. So a few things to say about this. Again, it does take practice. It's not easy, but this method is called comparing coefficients. It is extremely important because it can be used in many different type of topics, different modules, can anywhere where there's unknowns. So I highly recommend that you just get used to it and just get better at it. It may be confusing, but please shoot me a question if you don't understand this. Okay, so it's this. Alright, so solving after completing the square. This time solving takes a few more steps. So step 1, as usual, is let the whole equation to be equal to 0, and the next thing is make x a subject. So what we saw in the previous question is that we turned this into this, right? Using by completing the square. So now what we can do is from here we need to make x the subject. So what we can do is this: 3 x minus 1 square minus 2 equals 0. 3 x minus 1 square equals to 2. And we are slowly making x the subject. So we put 2 on the other side. Now what we can do is put 3 on the other side by dividing it on both sides. So, okay, x minus 1, right. Okay, so here is a very important thing. There's one very important thing to note. So when you're doing a square root on both sides, so what we basically did is we square root on both sides. But when you square root a positive number, you have to take note of this. There's this thing called plus and a minus, because in positive, it can be positive and positive multiplied by itself. A positive number multiplied by a positive number will give you a positive number, but also it is possible that a negative number multiplied by a negative number will give you a positive number. Therefore, when you square root numbers like these, it is important to include both the plus as well as the minus sign. So, okay, let's just continue on. And we have x equals to 1 plus square root 2 over 3, or x equals to 1 minus square root 2 over 3. And we have these answers. So quadratic equations, quadratic roots, they may have they may have 1 or 2 roots, and in this case this is how you get 2 roots. Okay, so that's all for this video. For the next video I'll be talking about factorizing by using the quadratic formula, which will be quite a lot easier than this one. But yeah, if you need more questions to practice on, just let me know. Otherwise, if you found this video useful, please click the like button and comment and subscribe to see more videos, and I'll see you guys on the next one. Bye.